Number 14, we're given a graph of f, and we want to use this graph to determine locations. So where are they of the local extreme, local extrema, and we want to write DNE for all extrema that do not exist. Okay, so that's what DNE stands for, do not exist. We're going to separate multiple answers with a comma. So looking at this graph, it has a low point, which is a minimum. And where is that occurring is according to the x-axis. You just got to count the tick marks. 1, 2, 3, 4, 5, 6. So at a -6, we're getting a low point. Local minimum at, and we'll say, I guess I just need the letter, the number, -6. Maximum at, there is no maximum, DNE. Now, why is there no maximum? Okay, because these arrowheads go up without bound to infinity, you will not say that 10 is the maximum because this graph goes to infinity. So we have a low point when x is -6. We do not have a maximum. All right, now part 2, I'm going to continue. Part 2, we want to determine the values of those extrema. So what is the y value? So this is -5, -6. So it's the same thing, -6, -6 is the minimum. So the minimum is -6. Maximum, DNE, don't exist. All right, and then for 15, we're going to be doing the same thing. We're going to use the graph, find the local extrema. Now notice there's no absolute maximum, there's no absolute minimum, but we do have a high point here and a low point. Okay. And this looks like it's counting by 5s again. 1, 2, 3, 4, 5. I mean, count by 1s anyway to 5. So we have right here when x is 1, we have a high point. When x is 2, we have a low point. So at 1 and 2, we have so the minimum was at 2. The minimum was at x equals 2. The maximum was at x equals 1. Okay, just telling it by location. All right. And then we want to know the value of those. This maximum is at 5, and the minimum is just one below it at 4. So maximum 5, minimum 4. Minimum was 4, maximum was 5.